Now, for a very exciting show coming up here, we have Mr. Mike Ruth talking about attacking and defending infrastructure with Terraform, how we got admin across cloud environments. So you have a background, I guess. You're working at Brex, right?
That's right.
InfoSec?
That's right. Yep.
All right. Well, take it away. Let's give him a round of hand up there.
Thanks, everyone. I want to say, it's great to see everyone, but I can't see anyone, actually, right now, so. But thanks for coming. My name's Mike. I'm a staff security engineer at Brex. My co-researcher, Oka, was unfortunately unable to make it, but just know that sort of all the slides and all the presentation and research that we talk about today, that was done through both of us, so big thanks to him. So yeah, I want to talk a little bit about our supply chain security, how we're attacking Terraform. In particular, we're going to talk about how we got sensitive credentials, as well as ultimately access into cloud environments. Okay, so I'm sure that a lot of you probably already know what Terraform is, but for those of you who don't, or perhaps a bit of a refresher, I wanted to talk about some of the basics, starting with what is Terraform. So Terraform is an infrastructure as code tool, right? And it's used to manage and deploy cloud resources, as well as a handful of other resources now, whether it's on-prem with VMs, Kubernetes clusters now has support, right? Vault, a handful of other things. They come in different flavors. It started as an open source tool, and for individuals who probably use the open source tool still, they're probably using it directly from endpoints, directly from laptops, right? So that means that all of your source code is local to the endpoint. All of your credentials to be able to get access to cloud environments and things like that, that's also local to your endpoint. Over time, though, the idea to productionize that so that you can remove those types of credentials from those environments, became more and more of an idea. And so HashiCorp came around and created this sort of productionized versions, right? These are things like Terraform Enterprise and Terraform Cloud. The scope of this presentation is going to focus on those latter two things, Terraform Enterprise and Terraform Cloud, and not so much on the open source version, predominantly because all the credentials and things are already local, right? For individuals or companies who may have productionized Terraform, their open source version of Terraform themselves, some of our findings might still be applicable, but just know that the majority of things that we're talking about today are through Terraform Enterprise and Terraform Cloud. All right, so let's talk a little bit about the internals of these services, or these tools. I think it's best to start with organizations and workspaces. So these act as logical boundaries. Starting with an org, you tend to have many workspaces inside of an org. Inside the workspace, that's where you sort of manage all of your resources. And these workspaces, they tend to be associated sort of one-to-one with your different environments, right? So you might have a workspace for your dev environment, a workspace for your staging environment, for your prod environment, right? You might also have workspaces specifically for a dedicated application, an application in dev, staging, prod, et cetera, but typically you have them per environment. Inside a workspace, you tend to have what's known as a state file, and as the name implies, it handles and persists all of the changes that have occurred, what it believes to be the state of your given environment. So this is useful so that when you go and make changes in the future, there's a cross-reference between what it thinks is currently out there in state, as well as the incoming changes, so that they can perform a diff between the two. The sort of meat of what happens inside of the workspace are all done by providers. So the providers are responsible for making all of the changes in your environment. So we might have providers for a bunch of different clouds, AWS provider, GCP provider, Kubernetes provider, et cetera, right? These are binaries that run, that are responsible for knowing about all of the resources that need to be managed, right? So it knows about all the configuration details, and it knows how to hit the responsible or the related APIs for that given provider to go and actually configure and apply those resources. Okay, a little bit about access. So for an organization who may just start out using Terraform Enterprise or Terraform Cloud, it may be such that you've removed, for example, all of the cloud credentials from your endpoints and instead have replaced them with Terraform credentials so that they can go and actually make requests to Terraform Enterprise Terraform Cloud, et cetera. And this works very much like a CRUD model, and it's on a per workspace basis. They don't necessarily call it CRUD. Instead, they use different terms: plan, apply, read. You can see their definitions here. Up until a couple of years ago, these were basically the only permissions that you could modify on a given workspace. But now you can actually use custom workspace permissions. And this is actually pretty relevant, in particular for the read-based permission, because read for a while meant being able to read the output of a given plan or apply, but it also meant being able to read the state and the state file, the contents of the state as well. So these custom workspaces permissions were actually now granular enough to only, say, allow read access to the output and not necessarily read access to, say, the state file, which you'll see might be relevant coming up here. Okay, so there's some challenges or perhaps some problems with having everyone at your company or anyone who needs to manage infrastructure at your company to be able to go and communicate directly to Terraform itself. So a more sort of mature approach might be removing access, all of those sort of individual credentials for being able to get access to your Terraform Cloud or enterprise systems, and instead use version control. This is actually pretty beneficial for a developer experience perspective too, right? Because you don't necessarily want everyone to go and learn a new tool. But most people are probably, or at least most engineers or developers, are probably pretty familiar with version control, right? GitHub probably in particular. And so the way that this works is you have a repository mapped to a specific workspace inside of, say, Terraform Enterprise or Terraform Cloud. So there's sort of a one-to-one relationship between workspaces and repositories. You might have a monorepo instead, where you have subdirectories that map to workspaces, but this is essentially how this works. And so when you have a repository and you go and submit either a PR or a commit to it, it goes and kicks off what is known as a speculative plan against the workspace. And that speculative plan is then responsible for doing like that dry run that we kind of talked about or that you saw on the access side of things. One thing that's worth noting is that speculative plans do not show up in a workspace's job queue. So job queue is basically all the list of plans or runs that exists for that given workspace. That'll be relevant for a little bit later, so just keep that in mind. When these jobs are created, though, we have sort of a set of nodes. The Terraform infrastructure is just a bunch of compute that's responsible for like doing all of the work that's associated with whether it's a plan or apply, right, all the job. And those are Terraform workers, right? Those are responsible for doing the actual work itself. And so the idea for this reference architecture is, you have these Terraform plans that exist. They provide dry run results, and then you go and look at the results, perform some sort of code review. If everything looks sane, you merge the PR, right, and then you actually perform an apply, and that's how your infrastructure gets modified, updated, and managed. So this is sort of a reference architecture diagram at a high level. We're going to be talking and showing this type of diagram a lot, and it probably makes sense to just sort of take a second here and look through it. So it's a pull request. The question was, what's a PR? So it's a request to go and make change to your version control to your repository. So a user goes and creates a pull request to the given Terraform repository. That goes and kicks off the speculative plan that we talked about, which just happens to be a webhook that gets configured on your repository for the specific workspace. You configure that beforehand. And so that PR gets triggered. The Terraform workspace has a job that gets scheduled on the Terraform workers. Then your resources are eventually managed after the Terraform plan gets reviewed, the code gets reviewed, merged, and eventually applied. Okay, so problem statement. We contend that in most organizations, most engineers have access to create PRs against your Terraform repository. So maybe a quick show of hands for individuals who use or have used Terraform Enterprise or Terraform Cloud at maybe their current organization or previous organizations. Show of hands, how many of these organizations sort of allow blanket PR requests to Terraform repositories? I see a handful. I mean, hold on. Yeah, all right, I see a handful, and it makes sense, right? It's good developer experience to be able to sort of allow many individuals to create PRs, and the assumption is that that's a safe action. So why is this a problem? All right, let's talk a little bit about our findings. So finding number one is all about secrets exfiltration. So we were able to access the secrets of a workspace through a Terraform plan, and in particular, a speculative plan from a PR. This allowed us to exfiltrate all of the Terraform variables, all the workspace environment variables, and all of the secrets that existed within that state file for that workspace. So some of the secrets that might exist in state, depending on your organization, might be secrets that exist in HashiCorp Vault. So if you have some sort of connection there, if you've got a vault provider, it would make sense to manage your secrets in such a location. But in doing so, referencing them in your Terraform workspace means that they end up also getting stored in state. Another type of secret might be, say, certificates or certificate keys. So if you're responsible for handling ingress or load balancers or any sort of front-end communication, and you want to do that in a programmatic manner, you might use Terraform for that. Well, certificates and keys, they might end up in there. Another use cases came as encrypted secrets. So if you're doing any sort of encryption in transit and you want to define, say, the ciphertext inside of your Terraform source so that it can be decrypted in sort of this programmatic fashion, well, all of the both the ciphertext and the plaintext might end up in state file as well. So we were able to get access to all of this, and this is sort of a workflow for how it worked. So step one, very similar to what we looked at for our VCS reference architecture. Instead of any individual creating a PR, well, now a malicious PR gets crafted, and that gets sent up to the Terraform repository, which in the same way kicks off a webhook that triggers a plan. That goes to the Terraform console, which eventually ends up being run on the Terraform worker, and then our malicious code kicks off and goes and extracts all of the environment variables that exist for that job, and either sends it back to the output of the plan if you have access to that. But it's just as easy to go and send that information, say, out to a remote listener that you've already configured ahead of time. Okay, finding number two. This is about state exfiltration. So we talked a little bit about workspaces being logical boundaries, and we talked about how each workspace has a state file. We were able to access the state files through a Terraform plan of all the other workspaces inside of an org. And we're able to do that from one individual workspace or any individual workspace. And so the way that this works is that whenever you create a job for a given workspace that runs on those workers, a token, a Terraform run token is what HashiCorp calls it, is created. It's also known as an Atlas token if you kind of look at the variable name. And that gets available with every plan and every apply. And it turns out that that token is sort of over-authorized. It has the ability to go and fetch the state from any other workspace that's within that organization. Similar workflow. Malicious PR gets crafted. Webhook triggers a plan. The plan goes to the console. That body of work gets kicked off on the Terraform worker. Then a malicious code runs. We go and fetch that token, probably using finding one, right? And then we can go and fetch the state from a given workspace by communicating to the Terraform console. And similarly, we either push the results that are in the state file back to the Terraform console, or you kick it off to send it to a remote listener. Okay, finding three. This is probably the most important finding. Apply on plan bypass. So it turns out that when you perform a Terraform apply, you can actually perform a Terraform plan inside of it. So our expectation, if we consider our reference architecture previously, there was an assumption that existed where when a plan was created, some sort of review had to happen prior to the apply step, right? That you needed to do the code review, you needed to merge the code so that you can eventually perform the apply. Turns out that's not actually true. We were able to perform Terraform applies through unmerged, non-code reviewed PRs. And they're super difficult to audit too, because they're those speculative plans that we talked about earlier. Because the speculative plans don't show up in the job queue, it's not easy to see. You have to go through audit logs that provide you with sort of a run ID, and so now you need to know exactly what you're looking for, or you need to come in sort of from the other end and know exactly to look at a specific PR to find it. Perhaps more importantly, depending on the use case, it also grants access to the underlying file system of that Terraform worker. So depending on your environment, this may or may not be critical. If you're using Terraform Cloud, then all of the workers are managed by HashiCorp themselves, and they're pretty well locked down. They have your own dedicated AWS account for you. They don't have any instance profiles or any extra IAM permissions. So while you do get access to the underlying file system, and you might be able to get remote code execution, you're not necessarily getting lateral movement here. However, if you are using Terraform Enterprise, you're responsible for managing those Terraform workers yourself, and that probably means that they exist inside your network. And that could mean that the Terraform worker has access through VPC peering or through transit gateways or some sort of access to all of your other environments that exist as well. And of course, privilege escalation is kind of the big thing here. If you have access to the underlying file system of your workers, chances are those are configured with some sort of best practice in mind, right? So that means if you're in AWS, the workers are using probably a assume role with Terraform profiles. If you're in GCP or Azure, you're probably using a service account of some kind. And in all those use cases, you can hit the metadata API to go and fetch those credentials. And because Terraform is responsible for managing all of your infrastructure and all of your accounts, it's probably admin level credentials that you then can get through that. So privilege escalation is very real. And the last point that I want to make on this slide is with the we don't talk too much about policy enforcement, but HashiCorp does provide Sentinel, which is sort of a policy enforcement framework. And more recently, they've provided run tasks with Terraform. And so the idea with these is that you can have sort of an advanced language to be able to enforce any sort of your unique or niche use cases that you want to sort of prevent these types of things from happening. But unfortunately, these things run within the context of a pre-apply and post-plan. So any sort of policy enforcement that you might be able to get out of these tools only applies after a plan, and since all these attacks are occurring during the plan step, we were able to bypass them as well. Similar to our last two findings, finding 3 is the apply on plan bypass. Again, malicious PR gets crafted, PR kicks off a plan, the plan goes and runs. We perform an escape from the context of the plan onto the underlying file system. And instead of sending the exfiltration results to, say, the console or to a listener, we actually just go in, we actually write malicious resources into the environment itself. Okay, so let's revisit the problem statement. If anyone in your organization can draft PRs against your Terraform repository, that means that they can exfiltrate secrets from any workspace. They can access the state file from any workspace. They can bypass all of this access control that we have in place, right, through unmerged, non-code reviewed PRs. And perhaps more important to some, get access to the underlying file system of your compute for your TF workers. Okay, so we have some demos. I want to show you that kind of illustrate the workflow that we just went through. So this is sort of the demo architecture, pretty similar to the reference architecture that we have looked at already. So we have this sort of fake hypothetical company, Crypto Exchange Co., and they have a repository that goes and creates speculative plans through this VCS integration, and they've got 2 workspaces, website dev and website prod. So basically they've got one website that works, and they've got a dev version of it, they've got a prod version of it. Because they use Terraform Cloud, their Terraform workers are all kind of within the same environment. And then the Terraform workers are then responsible for managing the resources in a dev cloud as well as in a prod cloud. Okay, so let's look at finding 1, which I think needs a second to load this video here. There we go. Okay. So we're going to run this get environment on the dev workspace. So we go and create a PR. The PR gets kicked off with a sort of innocuous or simplified name, creating a template instance, so it's very unassuming. We can see when the PR is created that the webhook is generated against the website dev. We go and take a look at the details inside of the Terraform console. And in there, our malicious code is running where we generate a null resource, 2 null resources, in fact. 1, to go and exfiltrate all of the environment variables, which you can see all the environment variables of the worker are just sort of listed here. And also the environment variable, the TF vars, which, as we can see, has, say, presumably provider credentials for AWS. Here's finding number 2. Similarly, we want to get the state file from our prod environment by running in the context of our dev environment. So again, we go and create a PR. The PR is run against website dev, as we talked about. We can see that there. The plan kicks off, and we can see again that our malicious null resource was created. And inside this, we'll be able to see the link to the state file right there. And then we sort of unfurl what's in there, and we see that we have database credentials from Vault configured. And those database credentials are associated with what appears to be the prod environment. So we've been able to get, say, an username and password for a prod environment through a PR from dev. Okay, finding 3. So we want to perform an apply on plan. For our example, we're going to go and create an S3 bucket. So this S3 bucket is going to be named remove this bucket. So when we go and take a look at our current environment, we can see that crypto exchange code does not have that S3 bucket. So we go through our same process again. We go and create a PR. PR goes and kicks off the Terraform plan, the speculative plan. We're in website dev. Malicious code triggers a null resource, and in here we can see that the Terraform apply is actually running. And we can see the output of the apply right here. Apply was complete and resources were created. So we can go back and take a look at the environment, remove this test bucket exists. So we were able to go and push resources through a plan, even though it was actually performing an apply. Okay, so next let's talk a little bit about remediations, mitigations, and some limitations to those. So the first thing that we thought was like, okay, I think we've got something here. What should we do? So the first thing was we should probably talk to HashiCorp about this. And so that's what we did. We ended up getting in touch with a couple of individuals from HashiCorp security team. We brought this to their attention. We had some of these conversations, and they sort of agreed that these were sort of legitimate findings. So the outcomes of these discussions were sort of twofold. Number one was that a security model, which consists of sort of a threat model, was created and available to everyone. And then the second thing was, well, there were some actual mitigations for some of these findings. I wonder if, does that help? Hold on. Slideshow. That's better. Okay, so this is the security model. You don't need to squint, and it's actually blurry, apparently. So don't worry about it. The link is there, and we're going to dive into each relevant section for each finding a little bit more. So don't worry too much about this. Okay, remediations for finding 1. So the first thing is, while we showed that this was applicable with speculative plans, it's still just as true for regular plans as well, right? If you have the credentials to go and interact with Terraform, you can make the same types of, you can use those findings as well. So if you're not using version control, and I guess regardless actually, you should probably implement the proper access control on Terraform Enterprise, Terraform Cloud, and all the workspaces, right? So this means that we should limit who has plan, apply, and view access on all the workspaces. If you are using version control with that webhook configured, chances are the majority of people do not need plan, apply, or view state. They might not even need to view the output. The only individuals that are probably need to do that are the owners or the individuals that are reviewing code. Secondly is probably implementing access control on GitHub, on your version control, right? So chances are you want an approval flow. You probably do not want by default everyone at the company being able to submit these PRs. So this is sort of, least privilege, if you will. The third one, which is probably the most technical control here, is you can disable speculative plans, and that's currently disabled by default. So you have to turn it back on. But if speculative plans are disabled, well, then plans aren't being pushed, and the avenue for these findings is basically gone. So here's a bit of a, all right, yeah, that looks pretty good. So this is the same workflow that we've shown on the previous slides, but now we're seeing it in the context of HashiCorp's security model. Starting in the top right, VCS contribution is the individual, right, the user. They may have access to go and submit a speculative plan, which ends up being able to read sensitive workspace variables, which is kind of in the bottom left here. Okay, so what are some of the limitations to these remediations, or these mitigations that we've just talked about? Well, the first one is even though you have all of these access controls on the given workspace, well, if you have a speculative plan that's running, it's going to bypass all of them, right? Because it has plan access. That's what it's responsible for doing. If you have access control on your version control systems, it's very possible that you've just implemented some sort of regression to your developer experience, right? It's really, I mean, when I asked with a show of hands how many individuals work at companies that anyone can push PRs, the reason for that is that it's very convenient to do that. So if you remove that convenience, you're sort of shifting the way that many individuals work at the company, and that might lead to some, experience problems. The most important one, though, is disabling speculative plans, because it removes that webhook. It makes it super difficult to review code. I'm not sure about anyone here, but for me, when I go and review a Terraform PR, the first thing I do is look at the plan results from that speculative plan to see what is changing and what's happening. And when I take a look at that, then I can cross-reference it with the source code to make sure that those two things align. And then I can go and sort of give the +1 on the code review. So without the Terraform plan, without the speculative plan, that gets super difficult. And oftentimes that might be a non-starter. This is part of the security model documentation from HashiCorp. One of the things was basically what is out of scope for their security model. And we can see the first thing here is malicious contributions to Terraform configurations and version control, right? And that's the demo, where those are all of our findings. So we can see why sort of finding 1 still exists. Even though we have some sort of mitigations in place, there isn't a surefire remediation. Okay, finding number 2. Much better story with finding number 2. So we talked a little bit about this Atlas token, or the TF run token, and how it was over-provisioned. Well, the most sane thing to do was actually reduce those permissions by default, and that's exactly what HashiCorp did. So they created, you can see the announcement link here on the slide. But basically the idea is by default, that token does not have access to all of the other workspaces within the org. However, if you would like to provide access to specific workspaces back, you can do that inside of the console itself. You can see the workflow here that we've talked about, but with the context of the security model. Again, starting in the top right, someone pushes a PR, kicks off the speculative plan. Typically, that means that the Terraform run token can go and read and get access to the state file for other workspaces, but with this change, that's no longer possible. And here's a little GIF that kind of shows that functionality in action. So we can see that you can share state globally, which is sort of the known bad default prior. However, the default today is with that off, and you can then, on a sort of workspace by workspace environment, add them back in. Limitations on finding 2. The finding still exists. We've sort of reduced the blast radius here. Unless all of your workspaces have this off by default, you're going to slowly add, the threat landscape a little bit more, right? One workspace might be able to have access to just one instead of all the other workspaces. I think it's a pretty good mitigation in those types of scenarios, though. We didn't talk too much about cloud agents. The cloud agent is basically the agent that you can put on Terraform workers or on compute to turn them into Terraform workers. So this is something that you might want to do if you wanted to manage your own Terraform workers with Terraform Cloud, for example. Basically, the cloud agents have their own token that can go and fetch jobs from the queue. And when you fetch a job, well, you get all of the environment variables that exist in that job. And so that means that you can potentially go and get access either to the state file or to any individual workspaces in the state files of those workspaces that it has access to. And we can see from HashiCorp's threat model that that's the case, right? Cross-workspace data access via cloud agents is still possible. Okay, finding 3. I wish that there was a better story for this. There aren't very good remediations at the moment. Finding 3 is pretty similar to finding 1, at least in terms of the access pattern, right, the exploit pattern, as well as some other remediations. So we can limit perhaps who can commit and create PRs. on the repository. We might be able to prevent speculative plans, but they come with the same sort of regression and developer experience that we talked about with finding one. There is a possibility of system-level enforcement. It's not something that we've looked too much at, but if, for example, your Terraform workers are running Linux, you might be able to use things like AppArmor, SE-Linux, things like this, and create profiles to ensure that all of those providers, the binaries that are running all of this code, they might not be able to do things, or you might have them configured so that they can't do things like run arbitrary bash or run Python scripts or things like this. It's worth noting that this is only going to be possible if you control the Terraform workers. If you're using Terraform Cloud and they manage the Terraform workers, this type of mitigation is not going to be available. Okay, so when we take a look at the security model and the pathway, there actually isn't an established route for this. When you take a look at the contribution and it goes and kicks off a Terraform plan, there is no line, if you will, to the Terraform apply operation. So it's not actually well established, which is probably why there aren't very good remediations that exist. So like we said, there's some limitations, and they apply mostly from finding one. And again, you're limiting the blast radius, which is great, by limiting access control and who can submit PRs, but it does not actually remove the finding itself. And we can see malicious contributions again. But if we think a little bit about it, if we could sort of be in the HashiCorp engineer's shoes, or if we could snap our fingers and provide any functionality, what could we think of for proper remediation for this finding? And so this was sort of something that we came up with. And I think that we see this pattern in the open source productionized versions where people have sort of full control. If they're not responsible for, or if they're not using Terraform Enterprise or Terraform Cloud, but organizations are instead using open source version of Terraform, and they've got the flexibility, I think we start seeing some of these things. So when we go and take a look at how the webhook triggers a plan, and step number 2, the Terraform plan should have its own dedicated permissions, right? Only read-only permissions for Terraform plans. Furthermore, it has dedicated infrastructure. Only plans run on this set of Terraform workers. Today, you have sort of a set of nodes, a bunch of Terraform workers that exist. Both plans and applies will run on those sets of Terraform workers. So in our sort of proposed model, we have dedicated permissions as well as dedicated infrastructure, right? Back to the basics, separation of duties and least privilege. That way, if we try to attempt to perform any of our findings, well, yes, you can still perhaps do read-based actions, but any sort of write-based actions that might happen to be attempted to be performed through the plans, well, they're no longer possible because the permissions just don't exist there. And that way, finally, when you get to the Terraform apply step, well, then you have a completely different role or different set of permissions that has read and write, and it's capable of performing read and write-based actions. The one thing that I will say here that isn't kind of listed is if you have the ability, again, maybe through this sort of open source version that we see, you might be able to put access control or policy enforcement kind of before the plan step. And that would be my suggestion as well, to say HashiCorp or anyone who has the capability of doing so, is let's consider these. How great would it be if we could just move those? They actually run pre-run or pre-plan and not after plan, right? And now we might actually have an opportunity to catch sort of these types of malicious code and things that we were running during these speculative plans and in our PRs. Okay, some conclusions. If there's anything that you take away from this, hopefully it's these 3 things. 1, all of these findings are still exploitable today. So be sure to go through the remediations that we've talked about if you're practitioners or users of Terraform Enterprise or Terraform Cloud. Bullet number 2, we should really have separation of duties and applies with these enterprise products, and I hope that they come soon. We should make sure that we have those separation of duties and least privilege. Number 3, secure architecture and the threat model documentation that HashiCorp put out, right? I think it's super important for practitioners to understand what the strengths and weaknesses are inside of the products that you're using, and I think that'll be super helpful to take a look at. Okay, last but not least, we didn't talk too much about the how here. We saw some demos and we saw some workflows. We just didn't really have time. So If you're interested, we've automated all 3 of our findings. It supports 2 entry models, whether you've got a repository that's associated with your Terraform workspaces, or if you have access to make requests and plans directly against Terraform with a Terraform client. You can go and take a look at the link here. Examples and usages are all on the README, but you can go and download that and use the automation for yourself. And that's it. Thank you very much for attending. Thanks again. Any questions?
Excellent. Good stuff here, man. I really appreciate your work.
All right. Should we take this as a cautionary tale against having, companies like Terraform with their commercial products do this for us? I mean, I thought that was a very interesting point. You're saying people who were working in open source, they may have some limited features compared to that commercial offering or more work to do. But as should this cast into doubt just the whole idea of infrastructure as code being outsourced to a for-profit enterprise like this?
Oh, I don't know.
Well, I mean, when do you think they might fix this?
Well, I don't know the answer to the last question, but I will say that there's a constant build versus buy challenge that all of our organizations face. If you have an infinite number of resources and an infinite amount of time, maybe you can go and build this open source version, and maybe you can go and solve all these problems. But lots of organizations don't necessarily have that opportunity, and I think this provides a lot. If the alternative is that all of your endpoints for all of your developers or engineers have AWS creds into prod, I think that this is probably the better approach. That would be my thought there. Any other questions?
One over here.
All right.
Hey, Mike. Quick question. I noticed your first 2 examples used null resources in Terraform. I couldn't tell if the third example did.
It did.
It did. Okay, great. So I would assume that we could also mitigate this by limiting the use of null resources in Terraform. Did you explore any ways of doing that while in Terraform Enterprise or Cloud?
I don't think that it will solve the problem, because null resource was just the one that we ended up using because it was the most convenient. But there are a lot of different providers that can do the exact same thing. You've got remote provisioners, which actually work on apply, but you also have HTTP providers. There are remote providers from remote marketplaces. So while I do think that trying to take a look at specific providers and not allowing them to run, that might be helpful. Again, though, a lot of the policy enforcement yes, I think that that's a avenue of research and investment, but a lot of times that might not be feasible. If you can get rid of everything, that might be able to work. I will say one last comment is we were able to exfiltrate all of the environment variables just using the AWS provider, right? We could actually set the name of a resource to the value of a secret, and it would just show up in the Terraform plan results. So I think it would be a slippery slope. I don't think it'll solve the problem, I guess, is what I'm trying to say. I think we'll find other avenues to do the same thing.
Okay, we got another question.
Hi, thank you. Great talk. I was wondering if there is a way to use other tools, like static code analysis tools, kind of like Chekhov or SEMGRAB, to develop detections prior to running the webhook. Like early as the steps of the pipeline, use some other tooling.
Yeah, possibly, right? So Chekhov is pretty cool because it does provide sort of this sanitary, inline, like even on a developer endpoint, right? It could provide some sort of feedback. It's not something that I've investigated too much, and I don't know what the extensibility of those types of tools are. I'm sure Clint might be here if he's a SEMGRAP expert, so that might be something worth talking to anyone who knows a little bit more about that.
Excellent question. All right, we got another one.
Thank you for your talk. It's extremely illuminating. I'm sort of already in a thought process about how to control some of this stuff, and we're considering taking on resource whitelisting or allow listing to attempt to mitigate some of this. And I'm wondering, I heard about the information leaking, but at the very least, do you think that would be an effective control against the arbitrary script execution stuff?
Maybe. I guess it depends on how you're doing whitelisting. I've read article like a vendor sort of customer articles that are in unison with HashiCorp that try to use Sentinel policies to try to do these types of things. The problem, I guess, that I mentioned, right, is it happens a little too late. So potentially you could do whitelisting. It just depends on where in your sort of supply chain you've put that. If it's prior to your speculative plans, then that might work. If it's a webhook that kicks off that prior to your Terraform plan webhook, or it's required to run before your Terraform plan webhook, maybe that's something that could work. Yeah.
Okay, other questions here? All right. Oh, good. Fantastic.
Hey, Mike, great presentation. Just a quick question, what would you say is some, or I guess kind of low effort, quick wins that you'd put into place just based off of everything, right? There was a lot of mitigations that could be used, but what would be some quick things that you could do easily to prevent some of these?
I would say that they're probably all of the suggested remediation points that I was suggesting, right? So it depends on each organization's environment. If you're using open source and you've got all your credentials locally, move to maybe an enterprise version or productionize it. If all of your engineers have access to the credentials in Terraform, let's remove those and perhaps use version control. If you have the capability of putting pre-configuration checks prior to your plans, that's probably a little bit more effort. But all of the access control for VCS and for these providers, I think, is a super important starting point.
Okay, cool. Other questions? All right.
And I guess one last point for anyone
Sure.
who wants the slides. I think I can upload them to the BSides site, or I'll put them on my Twitter as well.
And is this part of the show here? Up on the board?
Excuse me, what?
Oh, what is that?
Oh, I've been doing this whole conference, just summarizing.
Oh,
Pretty cool.
excellent.
I'm super pumped by it. I love that we have one here.
Got lucky.
Excellent work.
Lucky.
Look at that.
I'd like to
man.
think that I probably got
Now
lucky.
should get
I
a
probably got lucky.
screenshot of that. Yeah. Woo.
Thanks, Mike. I tried to follow along.
Woo. Okay, well, I can tell you I've learned a lot from this. I mean, I've hacked it before, but a different way. But now you just really took a deep dive on me. Are there any other websites of hacking Terraform that you know of?
Oh yeah, I've seen plenty. Oh, so we started this research in 2020. So it's been a couple years with COVID and all that stuff. We haven't had a chance to present it. But in that time, I've seen similar blogs and things like this have come out. So yeah, I don't know the links off the top of my head, but they're out there.
So that's great for red team exercise, pipeline poisoning, right?
Sure.
Okay. Last chance for questions. Okay, well, please give it up for Mike Ruth. In conclusion of this, sorry Francisco Aka couldn't make it, but thank you. And y'all have been a wonderful audience as well. So.